science is good.
I'll take it.
All right. It's weird for me to do two Samuels in a row since I left the helm of organizing the Samuels. But this is a good excuse. We talked with Adam about inviting him for a Samuel like a year ago, and now we managed the last Samuel, in valiant and brave people standing but sitting to hear Adam in the last moment of the year. I met Adam in 2003.
Thereabouts.
Maybe? Yeah, something like that. And then sooner or later, and unfortunately for him, I moved into his office. And he was pretty good enduring my weirdness. And then sort of we became friends, acquaintances with benefits, as they call it. Friendship benefits, okay? I knew you would be giggling in the wrong way. And he was always bright and very critical in a sort of very beautiful, sort of sly, cynical manner, very appropriate for a scientist, I would say. And I learned to enjoy that cynicism, scientific cynicism, not life cynicism. And then, things, life took him from the CBU here, but he was doing cool stuff about cognitive control and other bits and pieces that we might not talk too much about today. To Canada and then back to UK, and then he went to Imperial and started to build an empire there, as everybody does in Imperial. And then COVID hit, and he said, okay, this is my opportunity to make something good out of a disaster from a cognitive perspective. So this is maybe the most weird presentations he's ever going to get about him. But I think he's a wonderful scientist and a great person, and he might think that his presentation is going to be gloomy in terms of results. I think it's that as scientists we can separate aspect of emotion from the actual evidence, and if not, we might be all sad but wiser at the end of the talk. Adam, thanks very much for coming.
Thank you, Tristan. Great. So it's actually really interesting being here because I did my undergraduate at Cambridge, and my final year was experimental psychology. So that spot at the back, that was my spot for undergraduate lectures in the late 90s. It's really nice being back here. So presentation today is about COVID and cognition, and this is mostly what I'm going to be presenting is results from a platform that I developed over the last decade or so called the Cognitron, which is a system that can be used for very large-scale online objective and subjective assessments of cognition and mental health and other such measures. So what I thought I'd do in terms of structure is give you a little bit of information about the platform, because that's central to this research, and then talk a bit about a couple of the validation studies we did with it, which weren't with COVID. They were with things like traumatic brain injuries, dementia and prodromal dementia, and then move on from that to talk you through several of the more influential studies that we've run as a lab through the pandemic in relation to COVID and cognition. So first of all, what is the Cognitron? So Cognitron is a web-based platform that can deliver things like objective cognitive tasks through almost any type of personal device. That includes people's smartphones, their tablet devices, laptops, etc. And a lot of validation work and design work goes into making sure that the measures are valid, given that people are on different devices. It's fully automated, and this makes it very, very scalable. It's got more than 100 web-based cognitive paradigms that we've developed. So it's sort of like a tapas approach to cognitive assessment. You sort of go, which little short tasks is it that you want for a particular application? Got multiple language support, so if you want to run things in Italian or German, or something that has weird characters, you just drop a text file in and it will automatically put that in. We can run all sorts of questionnaires. It's got an inbuilt generator. It's very extensible, so if we want to put new tasks on, it may only take a few hours or a day of development to get those on because we pull in lots of templates and bits of code. Now, one of the key things is that it's very scalable rapidly. So we've handled up to 36,000 concurrent people being assessed on the platform. That was fun because we went from about 100 to 36,000 in 60 seconds because someone on a Horizon documentary said, maybe you'd like to try this at home. And fantastically, the whole thing scaled. It didn't break. And that, I still think that's a miracle. And it's supporting a growing body of studies. So now, outputs from it, in addition to the cognitive measures that we use for analysis, we can also instantaneously generate reports for participants and patients, and we can generate reports that can get pushed into e-health systems for clinicians. So, in terms of the cognitive tasks, I thought it might help if I gave you a few examples. Now, what we tend to do is try and redevelop tasks, and often they're classic tasks. Sometimes they're a bit more kind of pure in terms of new ideas and designs, so that they are suitable for web-based delivery. And there's a number of key aspects to how you do this, one of which is you need your task to be short. So if you give someone 10 minutes of lexical decision-making online, unsupervised, they're gone. So there's all the interesting things you can do online, you know, the world of information at your fingertips. So I try and keep my test down to about 90 seconds to 3 minutes max, which it requires a certain amount of design work to make sure we've got enough measures, enough reliability still to be useful. We try and make things minimally gamified to keep people engaged. And we try and make sure that they're reasonably accessible for patients as well. So there's quite a lot of sort of PPI and code design has gone into them over the years. Critically, most of our tasks, they have on-the-fly algorithms that generate the stimuli or select stimuli from problems from a large predefined base so that you can run them many times for longitudinal tracking. And in some studies, we'll even test people on a daily grain. I'll give you an example of one of those a little bit later. So 4 examples here. Top left, you can see a one-touch Tower of London that we use. So, you know, this is obviously based on a deep existing literature on spatial planning. Bottom left here, we've got a spatial rotations task, mental rotation task. We've got to work out which of these 4 matches this one at the top when rotated. Bottom right, we've got a word definition task. So you have to choose the definition that goes with the word, measures an aspect of crystallised intelligence, and the top right, you've got a spatial span task. So it's a bit like Corsi block tapping, where there's a sequence of locations flash, and then you have to kind of remember that and type them back in. Okay. So first example of a validation study. This was a traumatic brain injury, right? And what we wanted to do in this context is come up with a brief battery that was sensitive to deficits that people have after mild to moderate traumatic brain injury, so like concussions, that was minimally sensitive to what device they were tested on, and that didn't have a lot of redundancy in terms of which latent variables, which abilities we were measuring. And here we ran 100 people who had TBIs and 100 controls through a sequence of stages. So stage 1 on the left here, what we did, we took a superset of tasks, and each patient got a random combination of those tasks, because we can't run all of them, take too long, patients won't do it. And we looked at the effect size, which you can see in orange, of TBI versus control, and the effect size in blue of which device they're on. So is it a phone, is it a tablet, is it a laptop? And so first of all, we trimmed out all the tasks that were insensitive to group. We trimmed out as many tasks as we could that were sensitive to device, and we produced a subset. I then hierarchically clustered this subset according to how correlated the measures are, and removed measures that are too highly correlated. We don't need those. It's redundancy, and it will mess up our next step, which is a factor analysis, right? Particularly if some of those measures come from the same task. And then run a factor analysis, try and work out the latent variable structure, so what underlying abilities are explaining variance across this set here. And then we take a couple of tasks that load most onto each factor. And this gets us from this sort of large possibility of tasks through to a brief battery. It takes about maybe 16 minutes or so. Comprising these tasks, they measure different aspects of cognitive ability that are sensitive to TBI and, as far as possible, insensitive to device. And an example where we couldn't quite manage that is simple RT, because if you've got a more laggy phone, then there's no way around that. But we can actually model our way around that problem. Right. So, having done that and identified these tasks, we then looked at the relationship of the degree of cognitive deficit in these different abilities to the white matter disruption in the brain underlying different functional networks. And in essence, what we were looking to try and validate was if a task tends to activate a network after a TBI, is it the case if they have a deficit in that same task, do we see disruption in the same network? And that's that structural disruption in the same network. And that's essentially what we saw. So we published that in Brain. We then went on to look at the relative sensitivity of measures taken this way, and here you can see some of our factors that we were measuring, as well as a global score, relative to some of the sort of commonly used scales. So we've got the Mocha and the R-bands. These are quite brief, convenient scales, but they're very, very widely used in assessment. And what we did is we took a further set of patients and we subdivided them according to whether they were in the hospital for less than or more than a week. So they gave us a sort of a proxy for the severity of their injury. And what you can see here in blue and dark red is the Mocha and the R-bands don't do a very good job of differentiating this sort of level of cognitive deficit. They're going in the right direction, but it's statistically insignificant. On the other hand, the computerized tests that we ran online show strong dissociations, differentiation between these two groups. So we have higher sensitivity. Furthermore, if we cross-correlate pen and paper Mocha and R-band scales against computerized scales, we get a good multivariate correlation, which you can see here. And I like to think of this as being that we're capturing like a super resolution on the same impairments you might capture with these scales, but we have more resolution, we have more precision. By the way, if you have any questions as I'm going along, please do ask. Okay. Another example of the validation work we're doing. This is a deficits in dementia and pre-dementia. Now, so we ran populations who had mid sort of stage, early to mid stage Alzheimer's disease, normal pressure hydrocephalus, and traumatic brain injury across a set of the same tasks. And this is work by Martina Del Giovanni, which is in preparation at the moment. And what you can see is on the y-axis we have deficits in standard deviation units. So perhaps unsurprisingly, we're seeing really quite pronounced deficits in the AD group and the MPH group. The TBI is they're a little bit more subtle. One of the things that's really interesting though is the pattern here across the tasks is different. So you can see, for example, AD, we've got a much larger loading on the memory tasks, whereas with TBI, we're loading over here more on things like attention, target detection, trail making. Now, maybe this is unsurprising, but what's more interesting is when we applied the same tasks in the context of people from Insight 46. Now, Insight 46 is a birth cohort, people who were born in 1946, all within a few weeks of each other. And they've been monitored for a very long time. They've also been deeply phenotyped with imaging and blood biomarkers. So we know if they're starting to accumulate amyloid in the brain. What we did is we removed anyone who actually had a diagnosis of dementia or MCI. So we're looking at people who are preclinical, in the prodrome, if you like. And SUVR, this is a measure from PET of the amount of amyloid that's built up in the brain. And what we find is, looking at memory, people have less accuracy in their recognition memory when that is probed at a delay. The delay here is about 30 minutes, so it's still within the same assessment session. They also, at that delay, are slower in making that decision about which object they think it is they've seen before. And calculating this as the immediate versus delayed retention, so how much they're forgetting over that 30 minutes, you can see that also correlates. So we've got some sensitivity to changes in memory that are occurring right away at the beginning of that process. So anyway, that's some of the background validation work, and I've rushed through it very quickly, but I want to get on to like the main set of things here. So how did I get into doing research in the context of COVID and cognition? It wasn't deliberate. So round about the end of 2019, I'd been organising to put together a citizen science project called the Great British Intelligence Test with BBC Two Horizon. And this was supposed to be a bit of good fun. It would maybe get out there, test a few tens of thousands of people online, and look in the general population at aspects of cognition, aspects of mental health, and how they varied with demographics. Now, this was set to launch on January the 1st, 2020. And what happened was that BBC suddenly decided they were going to put it front and centre on their main web page, on their news web page, and push it out onto the app, onto the news apps that people have. And so I woke up early on January the 1st, and the website had actually broken this time because so many people were trying to get on there. And me and my colleague Pete Hellier, who programs the back end, were there desperately trying to get it to work. We got it to work within a couple of hours, and we collected a very, very large amount of data. Now, here's a sort of timeline data collection on log scale in 2020 from January to June. So you can see there's this big peak at the beginning here where we collected a good couple of 100,000 data sets. And this is right at the beginning of the year, and they're advertising things heavily. And they stopped advertising things, and it sort of trickled down. We've still got people coming through. And then we showed the documentary here in May. And of course, this is right bang in the middle of the first wave of the pandemic in the UK. And I thought, well, I might as well take the opportunity, because people have started talking about this thing called brain fog. And perhaps they're having trouble concentrating even after their main symptoms have gone. So I thought, well, I've got an opportunity here. I'll just put a questionnaire in about, have you had COVID? What were your symptoms? How bad was it? Did you have a test? Did the test verify you actually had COVID? So we did that, and we collected another 120,000 data sets over this time frame here. And this resulted in 390,000 data sets in 2020, 120,000 in May, and we had really good inclusivity, actually, even compared to your typical epidemiological study, which and it's only right, I think, is interesting. It's probably because we seem less sort of threatening in a way than a letter coming through from ONS or from some other government body. It's like a TV show that was pulling people in. We also asked a lot of information about things like personality, mental health, neurological and psychiatric conditions, etc. Okay. So out of the people who went online in May, 81,337 agreed to do the COVID questionnaire in addition to the cognitive tests that we were running. And what I did essentially was broke people down into these different, I stratified them according to these groups. So you got not ill, ill without respiratory symptoms without home assistance, respiratory symptoms with home assistance, hospitalised, no ventilator, hospitalised, ventilator. And this is supposed to give us kind of rough proxy of the severity of their illness. I also classified them this way according to whether or not there'd been a test to demonstrate they actually had COVID. Of course, the tests were less widely available at that point in time. So lots of people hadn't had tests, but there's a subset who were interesting because they had verified it was actually COVID they had. And of course, if we get to the higher severity range here, most people will have had a test when they're in the hospital. Are you with me so far? People with me so far. That's good. Okay. In terms of the time frame here, we're looking really early in the pandemic. So people are mostly a couple of months post illness. This isn't chronic. It's kind of like subacute. It's a subacute time frame. There are some people who are a bit longer, but mostly we're talking a subacute time frame. Now, just before I get on to the results, a key methodological consideration, this is a cross-sectional study, And there's a lot of things demographically that relate to cognitive performance, and one of those, of course, is age. So here are age curves for 390,000 people across the set of cognitive tasks we used in this study. And you see what happens for the most part from sort of age 11 up to, say, 19 or 23 is people quite rapidly improve. And then they're going to peak in their cognitive ability sometime late teens, early 20s for some tasks. Others, it's a little bit later. And then you get different rates of decline. You note this grey line going up here. This is the word definitions task I showed you earlier. So that's an aspect of crystallised intelligence. And you can see people keep improving at this. They keep acquiring words and their meanings right the way up into their 70s. I like to call this the wisdom curve. I'm somewhere in the middle here. So I'm starting to get wise. I've not declined too much in my other characteristics as yet. So of course, we have to take into account a model at age. There's other things we have to model as well in order to make sense of the relationship to COVID. So here are the things that I modelled in this analysis. Age, gender, ethnicity, handedness, country of residence, first language, pre-existing conditions, occupational status, economic status, depression, anxiety, insomnia, and tiredness. And all of those went into a normative model. And what I output at the end of that analysis is what I call a deviation from expected score. So how much someone's score deviates from what we would expect, given the large population model, after transforming everything into standard deviation units. So having done that, we now have deviation from expected units on this axis, and you can see here are different groups in terms of COVID severity, and it's a really striking relationship. So at the far end here, you can see they're down by about half a standard deviation on average if they went to hospital and were put on a ventilator. And then we scale in quite an elegant way. But you see on the left-hand side, what's interesting is symptoms but without respiratory symptoms. So our mildest group, that's still a statistically significant effect. It's just effect size is negligible. Now, of course, at that point in time, many people thought they had COVID, didn't have COVID. So you had the flu, you had the cold, you had a bad stomach. You think maybe that was COVID, right? And so the question is, if we then subdivide these groups here, according to those who did versus did not have verification using a biological test, that they had COVID, do they differ? And the answer is that they do. So the ones who had verification are down by about 0.2 standard deviations compared to the ones who didn't. So this, I kind of interpret as there's lots of people who thought they had COVID, but they didn't have COVID at that point in time. Just drilling down a little bit more in terms of, I suppose, just taking an overall composite of cognition, looking at domains, we can see things like semantic problem solving and attention. We're showing larger effect sizes here. Spatial working memory, not so much. And we've got verbal analogies and word definitions. Tower of London and executive tasks. So sort of reasoning, attention, executive functions, these seem to have a higher sensitivity, at least in this analysis. And I'm going to come back to that later with other studies. So, there's loads and loads of limitations to that initial study. It was also pretty much the earliest one that showed these sorts of associations using objective cognitive tasks as opposed to just subjective self-report. On the back of that, I got approached by lots of groups about, can we now use your software in our various funded studies? And of course, these are all studies that have been funded. I wasn't on the grant applications, and I ended up doing most of it for free. Not that I'm bitter. Anyhow, so one of the first of these, which was great collaboration actually here in Cambridge with the Cambridge Euro COVID group. This was run with David Mennett. And here we were looking at people who, I guess you could say, were sort of back. If you think about like these two groups, so the most severe groups, what we're doing here is we're coming back and we're saying, what about a hospital cohort, people who came through critical care, and now we have certainty. It's not just self-report, we have certainty they went through critical care, and we know quite a lot about what happened to them in the acute illness, so you know the WHO severity scale, high CRP, mechanical ventilation, time since illness, extrapulmonary support, highest D-dimer, etc. So you've got all this detail about what happened to them acutely, and then we also measured their mental health in terms of things like GAD-7, PHQ-9, and PCL-5. So you're looking at, for example, anxiety, depression, fatigue at the point in time where we assessed them, which was 6 months to a year later after their acute illness. Now, at this population size, relatively small, 46, but we're expecting quite big effect sizes, so that's defensible. We can't really look at all these individually, all these features. So what I did was I factor analysed them, and then we've got 3 factors. One of them was capturing a lot of the features to do with the acute illness. Second one, a few more of those acute illness features. And the third one was mental health at the time that we assessed them, right? And what we found is it was the acute illness severity that was predictive of the scale of their cognitive deficits. So on the top left here, you can see overall as a group, their deviation from expected scores were lower for accuracy, higher for response time. And the degree to which that was the case correlated with their acute severity, both accuracy and response time, but not for their mental health status at the point in time where we assess them, which helps rule out an important confound. So that shows a really nice sort of replication of what we found with the big citizen science project, but only at one end of the severity spectrum. Looking in more detail, this breakdown of the different cognitive tasks, so you can see these global composites on the right-hand side here again, that I was just talking about. But on the left we have accuracy, on the right we have response times for the battery tasks. And you see verbal analogies again, 2D manipulations, words immediate, so that's a memory task, spatial span. So we've got tasks to look at, reasoning, attention, executive function again. These are kind of like popping out to me and seem to again have some relationship to the pattern that we were seeing in the citizen science work. This is in e-clinical medicine. One thing that was interesting, and I'll come back to this later as well, is there seems to be additional visuospatial task deficits that we hadn't seen in the milder cases in the citizen science work. So I'll return to this in a bit. So what about similarity to other populations? So we're able to look at, for example, the pattern of deficits we see with some of these tasks in COVID-19. We've run some of the same tasks. Let's say dementia, we say is it the same pattern? Again, accuracy on this side, response time on this side. You see the pattern's quite different. Dementia, it seems to be hitting things like memory tasks more. Some of the effect sizes are a lot bigger. That pattern seems different. And then normal aging, so the difference between 70-year-olds and 20-year-olds, 70-year-olds and 50-year-olds, it's not the same pattern. So this doesn't look like accelerated aging. It doesn't look like dementia. It looks like something distinct on a multivariate level. That makes sense? Yeah. Okay. I'm drying out, sorry. So on to the next study. So REACT was one of the big studies that was run during the pandemic, surveying people. It's run in, there's the ONS study, and then there's the real-time assessment of community transmission. This was led by Paul Elliott, Helen Ward, Graham Cook, and others at Imperial. And what they basically did during the pandemic, they got the database of everyone in England who signed up with a GP. That's near universal coverage. And then they did random sampling, sending people testing kits, and then people would send barcode back the testing kit, and they fill out a survey. And they had about 3.5 million people that they surveyed in this way through the pandemic. It was really interesting, that cohort, is they also captured people who didn't know they had COVID and were asymptomatic, so they can even extend down further than my citizen science work. There's also a lot more certainty about their demographics, and it's a nice balanced sample. It's got less bias in it than my citizen science work. Now, out of that 3.5 million, 2.4 million signed up and said, yes, I'll take part in future research, and they gave consent for linkage into their clinical records. So this is a massive and very, very important, useful cohort. Now, what we did is we followed up, emailing off my platform 800,000 of them to say, will you go online and do a cognitive assessment? And we did that towards the beginning of last year. And out of those, 141,000 went on and they started a cognitive assessment. 112,000 approximately, they completed a full cognitive assessment. And we captured a whole set of information before that about their current symptoms, circumstances. And we sought to try and address some of the following questions. So, using the global cognitive scores and adjusting for things like pre-existing conditions, age and other demographics, whether those who had recovered from confirmed COVID-19 had global cognitive deficits relative to those who had not had COVID. And we wanted to know whether the effect sizes of those deficits related to a number of things. Period of the pandemic, when different virus variants were dominant. Illness duration, for example, were they asymptomatic? Was it the case that they were better within 4 weeks or under 12 weeks? Did they have symptoms that persisted for more than 12 weeks, but by this stage, when we test them, had resolved? And did they have ongoing persistent symptoms over 12 weeks, which would put them in an ongoing long COVID category? We also looked at whether they had sought and received hospital treatment, whether they'd been vaccinated at any stage, and whether symptoms of poor memory or difficulty thinking or concentrating, so people self-reporting that they have brain fog or memory problems, has some correlation with their actual objectively measured performance of memory and cognition. Is this making sense? Yeah, good, thank you. So the first, and we published this at the beginning of the year in New England Journal of Medicine, which kept me up doing very long hours and almost no sleep for a long time, because they're a very difficult place to publish. So first plot here, we've got global cognitive deficit on our battery of tasks on the y-axis, and we've got days since the beginning of January 1st, 2020, when they first became ill. Okay, they're all being measured at approximately the same time. So for some of these people, it's been several years, right? And what you can see is the cognitive deficits that we see in red are on average larger than we see in more recent variants. So that's people caught out in sort of wild type and alpha time frame. They're showing cognitive deficits. Actually, if you look at around Omicron, which is up around here, we're not seeing any cognitive deficits at all. So that's interesting. I then adjusted this analysis, adjusted the model for a number of things, such as which virus variant we thought they had, how long their illness duration was, were they hospitalised, and actually that kind of normalises nearly the whole time frame. So those variables seem to explain this difference, right? Apart from here, which is about 100 to 200 days in. That's interesting, because that's when the hospital systems were overwhelmed, and a lot of people who should have been going to hospital and treated, they didn't go to hospital and get treated. That's what we think went on there. Tristan?
When was the first vaccine?
Oh, now you're asking. I'm not sure.
Because, you know...
But what I should say, actually, I know it's probably not in here just for time's sake, but we were able to subdivide people into those who were versus who were not vaccinated. And there's definitely a cognitive advantage for people who got ill but were vaccinated relative to those who were not. It seems to be largely mediated by these variables, though, the variables I mentioned that we adjust for. And furthermore, the associations that we see, if you look at the unvaccinated, they all still hold. So one talk about it's not driven by vaccination, but vaccination was a good thing to do. Yeah. Okay, so first of all, in terms of distribution, so what we have here now, we've got these are probability distributions. We've got proportion of participants from each of these stratified groups who are performing on a standard deviation scale within these cut-offs. So 0, and that's just average, but expected performance. -1 is that'd be -1 standard deviation from expected, -2 standard deviations from expected, etc. After doing all these adjustments for demographics and things like that, I'd say some -1 is their performance isn't it's a bit low. I wouldn't say I have a deficit. If you're at -2, then you don't have a mild deficit. You have a moderate cognitive deficit. And what you can see here, so we've got original virus, that's wild type. We've got alpha, delta, omicron, going from left to right, and then we have no COVID in grey. And you can see the whole distribution for the original virus variant and for alpha, it seems kind of like shifted left just a little bit. And we've got fewer people in the higher performance range here on the right as well. These are small effects, right? They're small, but with 120,000 people, they're statistically significant. I then looked at illness duration. So we've got more than 12 weeks unresolved, so they still have symptoms when we test them. More than 12 weeks resolved, they had, well, it was probably long COVID, they don't have it anymore. 4 to 12 weeks, less than 4 weeks, asymptomatic, and they're going to grow no COVID. Now we're looking at more like medium-sized effects. You can see these distributions, that the whole sort of Gaussian has shifted left to a greater degree, particularly for the unresolved group. And then I looked at hospitalisation. So were you in intensive care unit? Were you admitted to hospital? Did you just visit the emergency department? Were you ill but you didn't visit the hospital? You have no COVID. And now we're in, not small effect sizes at all. You can see the whole curve's got shifted left. Whole distribution. And if you look at the group here, where I was saying these are moderate impairments, and then compared to no COVID, this is a big increase in terms of the odds ratio. So I brought all of these things together into a linear model, and these are what the results are. So going from the right-hand side, you can see that people who are in intensive care, they're down by about 0.4 standard deviations in their global cognitive performance. ED visits with smaller effect size, the hospital admission, well actually they're pretty similar. In the middle, illness duration. So these, unresolved long COVID, these guys down by more than 0.4 standard deviations again, right? But interesting, look at these guys. So you've got 12 weeks symptoms, but it's resolved, and they're performing at the same level as even people who are 4 weeks resolved. So that's positive. It means maybe if you have long COVID and eventually your symptoms resolve, maybe your cognition might improve to some degree as well. But sadly, everyone had COVID, even the asymptomatics are performing less well than the no COVID reference group by a small amount. Again, that kind of fits with what we were seeing in the subacute phase, but now we're kind of seeing it at a several year offset. And then over on the left-hand side here, you can see that there's an advantage to having got ill in the Delta or Omicron period of time relative to the original virus or the Alpha variant. I would suggest, something's going on here with the virus, having less of a cognitive effect, perhaps over time. But of course, these are associations, so I shouldn't use the word effect. Now, this is a linear additive model. So, for example, if you're in ICU and you still have ongoing symptoms after more than 12 weeks, these terms are additive, right? So you could be down cognitively a long way. Next, I thought I'd look at the multivariate patterns across the individual cognitive tasks for illness duration and for hospitalisation. Okay, and these are all accuracy measures now. And this is, this is a set of tasks that we were using. In dark red, we've got the 12 weeks under unresolved group gain, then different levels of duration, and these are all relative to the no COVID group. And what you can see is delayed memory, immediate memory. So our memory task seems again to be showing particular sensitivity here. Word definitions, so that cropped up before. Verbal analogies, memory and executive function, they keep cropping up here. Right, reasoning as well, keep cropping up as being particularly sensitive. But look at these guys, so hospitalisation. In dark green, we've got intensive care. So down here, 2D mental manipulation, so visual spatial manipulation. We've seen a big deficit in the ICU group that we do not see in the long COVID group. And recall I was saying this is something we saw earlier when looking at the Cambridge neuro-COVID research for those 4 to 6 people. So we've replicated that again, but in this larger study. And then I had a look at which aspects of cognition correlated with brain fog, right? So did people say they had brain fog or not? I stratified them into 3 groups. In red, we've got people with ongoing persistent COVID symptoms. In yellow, we have all people who had COVID put into one group if they no longer have symptoms, and in grey we have controls. And of course, even people who don't have COVID, they quite often say that, well, I have brain fog. And what's interesting is the ones with the ongoing persistent symptoms, you can see this these correlations, like with higher response times and poorer accuracies, particularly on things like memory, delayed memory, word definitions, verbal analogies. So the same task cropping up again. But this pattern, for people whose symptoms resolved, it's attenuated, right? But it's still there. people who didn't have COVID, well, actually, there's hardly anything there at all in terms of the associations, much smaller. I think that tells us something very interesting about brain fog, which we won't go into too much detail today. But of course, it's something that people self-report, and it's a very, very complex construct. For some people, it's like heightened awareness and concerns about, cognitive failures might be perfectly normal. For other people, there could be an objectively measurable deficit that is leading to those concerns. So any research looking into brain fog needs to consider the complexity of what brain fog actually is. And a lot of the time at the moment people are lumped together. Have I got time for the last bit? Yes. Okay. So what about change across time? None of this has told us very much about cause and effect. We're looking cross-sectionally. I can get a little bit closer to cause and effect in the context of research we just published in Clinical Medicine on the wild-type SARS-CoV human challenge study. So who's familiar with what a human challenge study is? Okay, so human challenge studies are where you deliberately inoculate someone. So you give them a challenge. And often they're used in the context of things like validating flu vaccines. So you challenge them, you give them vaccination, and you can contrast. And as opposed to doing a big epidemiological study, you can do something quite focused that is sufficient because it's controlled to, validate, for example, that vaccine. And they thought that what they would do is run a human challenge study in the context of healthy young volunteers using wild-type SARS-CoV-2 virus. And what we did was we cognitively assessed them for 2 days at baseline before they were inoculated, every day for 2 weeks, whilst they were in the centre, the trial centre. And then at the end of 2 weeks, if they're well, they were allowed to go home. Otherwise, they're kept in the centre until they're well enough to go home. And then we followed them up 30, 90, 180, 270, and 360 days. And actually, quite fortunately for the analysis, that inoculation in exactly half of the volunteers took, and they had sustained viral load, and that's what you can see in green here. So this is viral load on different days. You can see it all kind of kicks off after about day 3. Okay, so inoculated here. At the top you can see the unaffected, and at the bottom you can see the infected. So I'm going to contrast these two groups in terms of their cognitive performance. So taking a global composite and correcting it against their own baselines, if we look first of all at the grey line here, which is the uninfected across time, you can see what happens. The first time you do, a couple of times you do the task, you improve quite a lot. You're learning on some of the tasks, and then through this period of time where we test them every day, they kind of improve a little bit more, and then they start forgetting the tasks over time as they get up to a year because we're testing them less frequently. So you get learning and forgetting effects on tasks. Now, for the people who were infected, you can see that they kind of drop from day 3 down to like midweek here, and then they kind of stay dropped up to a year. And in fact, there's no recovery trend here. They just seem to kind of perform worse, and they perform worse in a sustained manner. Now, one of the worries here could... I've not got the slide on this, so I'll just explain it. One of the worries here, it could be, is this all mediated by learning effects? It could be that whilst you're ill, you learn this, right? So we then reran the analysis using only the tasks that have no learning effects. And half the tasks, there aren't these learning effects. And you see the exact same result. And not only do you see the same result, it's the case that then the infected perform worse at a year than they did at baseline. And so, again, what we didn't have here, just to clarify, this is it's a challenge study, not a challenge trial, and that's because there's no placebo group. So I'm not going to make a really, really strong claim about cause and effect, because they had no placebo group, but think about the alternative explanations. Now, what about drilling down again, which tasks show the highest sensitivity? Well, look at this, object memory again, immediate and delayed, Tower of London. So we've got some of the same tasks cropping up here as the most sensitive. What's really interesting though, and going back, I'm not sure if you recall, but when I was talking about the dementia validation work, object memory, that was the most sensitive task, right? and it had these nice correlations with SUVR, right, amyloid deposition. But the nature of the deficit is different. So for people with amyloid deposition, what you see is accelerated forgetting. We're testing their memory twice, right? Different time frames, they forget faster. But here, people are, oh, what's happened there? No. People are doing worse at immediate memory. Yeah? So they're not encoding things right in the first place. And that suggests to me what we're looking at is probably more closely related to attention than memory consolidation or forgetting, right? It's quite a different pattern of results. It's the same task, but it's a different pattern of results to Alzheimer's. Right, that's me on my summary. So, in summary, there's a convergence of evidence, I think, that COVID-19 is associated with persistent, objectively measurable deficits in cognition and memory function. Cross-sectionally, we can see it even if we have very large population samples and we're trying to model as many compounds out as we possibly can. It's even evident, albeit small but detectable, in people who've had short duration illness, particularly early in the pandemic. And it scales with the self-reported severity and actually clinically reported severity of the acute illness. It doesn't correlate that much with the mental health status of people at the point in time where we assess them. And you can see it a year or more, even several years after infection. This seems to be more the case for people who were caught early in the pandemic. And it's also more the case for people who have longer duration illness, although it could be, based on the evidence here, that once those longer duration symptoms eventually subside, there's some recovery can be expected. That's kind of positive. And probably that's the bulk of it. I suppose the other thing is, one of the things that results highlight to my mind is, if you look at the critical care group versus the long COVID group, the pattern of deficits is different. And it's probably a mistake just to think, well, there's a mechanism that underpins what we're looking at here. We're probably looking at multiple mechanisms. If you want to get towards treatments that work, then you probably need to be working out how to subclassify people and how to target the mechanisms that are specific to their COVID problems. Okay, I'm going to skip over this because of time and just thank critical people, particularly people in my company, HCCD, who sat supporting so much of this work, and often we took no money for it. We had a bit of money for React. Collaborators in React, so Paul Elliott, Helen Ward, Sam Chamberlain, John Grant, Little Meta, David Mellon, Richard Nicholas, Michelle Kuhn, Steve Williams, all of whom contributed to various of the studies that I've covered here today, and particularly in the lab, Anna Lara Reed, Aim Jolie, Ziwan Kai, Maria Ballet, Valentino Guinciuga, and Martina Del Giovanni, who've put a lot of hours into this work. Thank you very much.
Right, it's customary for those who need to go quickly for whichever reason can go now, and those who stay will have a nice discussion with Adam before we go for drinks. And those who stay for discussion can come for drinks. I'll pay for the drinks, at least the first drink. Seriously. Sorry, the department will pay for the drinks. And there's still some spaces in the dinner if someone wants to come to the what's the thing? Where we no, Petra was full. What's the
I can't remember.
I'll check. It's one on the way.
It sounds like fancy.
The Bengal
like fancy food.
The fancy Bengali
Yeah.
one. Yeah, good. Right. This is a good ratio from people who come for those brave to stay for discussion. I have too many questions and a couple of suggestions, but I will not start. You will start, and I will give priority to young-looking people, as you know well. Eddie.
Thank you so much for the talk. As someone also working in online testing, I'm followed by the large sample sizes and the participation. So I was wondering if you have any tricks for like to impart on how to incentivize the participants and well, maybe identify participants who are not attentive during the tasks.
Oh, well, those are two different questions. So how to incentivize people? The best way to incentivize people is to give them feedback on their results. And so what people hate doing is putting effort in, and obviously doing cognitive tasks is effortful. Actually, filling out surveys is even effortful. Cognitive tasks also. If you ask them to do that and you don't show them their results, then that's kind of a bit mean. They're firing their data off into the ether. And you can see that with clinical populations with monitoring. You know, they want something back from it. That's probably the most important thing. You know, so for like a big cross-sectional study, the way in which I tend to sell that is in quite a positive way, and I'll be saying, look, we're going to measure all these different dimensions of your abilities, and what we're going to do is show you the end of the report, explain to you what your strengths are. And so we'll configure the whole results page around this is where you did best. You know, of course, we show them the whole picture. That seems to work very, very effectively, as you can see. You know, with the GVIT study, in the end, we had probably about 500,000 people in the UK went on and did that absolutely for free. They just volunteered and did it. With clinical populations, you know, if it's for sort of monitoring purposes, then the danger is what you do is you say, well, you go and do this online, you know, repeatedly, and they'll do it maybe once, twice, and then they stop because they're getting nothing out of it. On the other hand, if what you do is say, if you do this, then it will get formed into a report that goes to your clinician will talk to you about it, it will inform those decisions. When you see them, almost all of them will do it, in my experience. Your other question was
about data quality checks.
Yeah, so we've got like lots and lots of tricks of the trade for checking data quality. Some of them are relatively obvious. So you know, just look at the performance distributions, and you can see, for example, there are people who are just curious and they'll speed tap. But then on a distribution of response times, you get like a little peak, and then you get the main distribution. So you just kind of cut the people off. Or obviously not, you know, it doesn't take half a second to do a complicated Tower of London problem, for example. Not unless you're a computer. There's things like loss of attention actually within the device. So people sometimes they try and cheat, and if they try and cheat, the sort of typical thing they'll do is like click from the browser, they'll click on something else, type the numbers in, you know, so they're not remembering it, or else they'll sit and write it down. We can detect that because from a browser you can see if you lose the focus. And we can also detect it from the pattern of someone's response times, because you have a distinct pattern of response times to something like a span task, right? So there's sort of model-based and processing approaches you can use to kind of detect people who are misbehaving. There's a whole set of them, but I won't bore you with the whole list. Right?
I'll read the thing.
But what is interesting actually is when it comes to the big population data, you can apply filters, the quality check in that way, and you see pretty much exactly the same associations whether you do or don't. And that's because you've got so much data. You know.
Iriana,
Yeah.
Thanks, Adam. That's bleak overall as the message. So a couple of sort of questions, comments. Reinfections. Is that sort of making stuff even worse? Because most people would have had it a couple of times, multiple times.
Yeah, so we looked at that.
Was that a factor?
I looked at reinfections in the New England Journal of Medicine paper. I didn't have time to talk about it, and what I found was that if you analyse it very crudely, it looks like reinfections are bad cognitively. But in reality, if you model it in detail, you find out that's because if people had multiple infections, they're more likely to have had one early. And that's actually the key thing. So imagine, you know, you had like wild type and then you had Omicron, there's almost no additive effect of that.
Okay. Yeah. I guess that's positive.
Yes.
The other question, I guess, more serious, is have you tried to link this to any mechanisms, to any neural data, to any, like, what is actually happening in the brain?
So yeah, to some degree, I'm going to be a bit tentative about that. So in the study with David Mennon's group, we did also look at blood biomarkers, and I think we saw. No, it wasn't that one. No, sorry, it was in the challenge study. It was in the challenge study we looked at blood biomarkers, which I got them to do retrospectively, and we saw. I think it was an increase in GFAP in those who were successfully infected, but there's too few people to do a correlation between those markers. Obviously, that's something that's elevated in post TBI. Then we've got another study from COVID CNS that came out in Nature Medicine recently. I didn't have time to talk about, and that was looking at people who had neurological complications. But I hesitate to try and draw too many conclusions from that in terms of there's such a complicated population, because you've kind of, they had a stroke or some other neurological complication on top of the fact they had COVID. So it's quite hard to disentangle the mechanisms. There's some really nice work looking at subtyping and trying to understand mechanisms, which we also contributed to. That came out of Maxine Takei's work up in Oxford. That's worth having.
I mean, I was just trying to basically look at various tasks and whether there is anything that can be drawn from there. So obviously memory seems to be quite prominent.
But I don't think it's memory in terms of retention. I think it's like an encoding problem. And there's something. I'm being really speculative here. If you look at the pattern, where they'll have like fatigue. They report brain fog. They have these types of memory attention related deficits. That looks a little bit like people who had a TBI and brainstem damage, right? So I do, and there's been recent work again from David Menon, Ed Bullmore, some of the others here, James Rowe I think as well, so on that showing brainstem changes in people post-COVID. Right, so that's come out recently. So I do wonder if there's some connection there. But you really need to take these sorts of precision, objective cognitive measures, and then look at them in relation to those biomarkers, right? So we don't know yet.
Yeah, because of something like verbal analogy comes up very often in quite a lot of them, but that sort of would be more. It's not episodic. I mean, it's a task. It's a different verbal task. Something that would be one of those things that retains over time. It's just
how to map it. I know we just can't without bringing those measures together. I spent a lot of time trying to think that through as well. We don't know yet. Yes.
Absolutely great that you were able to capitalise on the situation you encountered at the beginning and get such exciting results. This just question about the sample of people who you're looking at. The first one is a very obvious one. That is, there are some people who are willing to fill in, who are willing to do these tests, and there are other people who aren't. And I imagine in some of your work you might have some idea of what proportion of the world will actually do this, and therefore how representative the whole thing is. It would seem to me that it should be okay, but that's an issue. And another thing was, one of your results was that about people who were vaccinated and not vaccinated.
Yes.
And then there's a question about the kind of people who are vaccinated and the kind of people who are not vaccinated and what their abilities are likely to be. Do you think that there might be a difference between the sort of people who are vaccinated and the sort of people who aren't?
Yeah, so there's a couple of questions there. First one to do with bias. There's always bias.
Yeah.
Of course, yeah. And so all we can do is try and model around it and do very stratified analyses. And obviously, to get into New England Journal of Medicine, they kept me up like ridiculous hours doing lots and lots of reanalysis with exactly that type of question until, we couldn't break the associations, whatever way we modelled around it or stratified. So I'm reasonably confident in it, but certainly there's bias. I mean, there's bias in who's going to respond. Tried looking at things like whether the severity of the illness that people had was biasing whether they took part, fatigue, various other things. None of those seem to really explain it. At the same time, with a big epidemiological cohort like that, when you go out and read contact, you do tend to find you get more older adults, you get more people who are higher education, some demographics in terms of ethnicity are more likely to take part as well. So you have to model around that carefully. I think a lot of those sorts of concerns in terms of an explanation are mitigated by the challenge study, because that's all individually baselining. And interesting, that population, they don't even report brain fog. They report no subjective cognitive problems, and yet we were able to measure something subtle that changed. What was your second question?
Vaccinated or not?
Vaccinated or not. So I subgrouped people in a supplemental analysis into those who had and those who had not been vaccinated at any point. And the set of associations that I showed, they remain the same. Of course, there's whether as a group, those two sort of strata differ to each other a bit. I didn't actually check. I probably should, but it's an interesting question.
I mean, you might think that people who didn't get vaccinated might have had less ability to evaluate the world.
Well, quite possibly.
Or it might be something else.
Quite possibly. You're probably right about that. Yes.
Fight.
A test theory question. You used the classical approach to battery reduction with factor analysis and leaving, I think, 2 marker tests on each hypothesized factor.
Correct.
As a result of having had this absolutely immense sample, although relatively short amount of material from each respondent, would you recommend for the next pandemic a fine-tuned or mini cognitron to do a similar sort of exercise on whatever that pandemic turns out to be?
Well, it's interesting you should ask, because there is discussion at the moment about whether we can retain not just the cognitive part, but the surveying part of this that went into React, a reduced variant that's just kind of like sat there, ready to go whenever there's another pandemic. That's something that's being looked at the moment. And yes, I think you could reduce it down from what it is. I mean, to my mind, it's really fascinating actually that, you know, that immediate memory task takes 2 minutes.
Yeah.
It's the most sensitive task.
That's a lot of punch.
Yeah. So that's you know, because if you said to people on a survey, we want to do something, it's going to take you 2 minutes. You can get a high response rate.
So I've got a couple of related questions. So the first question is to do with ageing. So I know you sort of partially addressed this with your small last study, but I'm still a bit worried by this generally, because you've got a massive ageing effect, both with COVID and with cognition. So with your sort of linear models, you would have factored out ageing, but what if it's a non-linear effect? So can you have a sanity check, so you just cut off with your big data up to 40, and do you still see the same effects? That's the first question.
This is being done in 2 ways.
Yeah.
So the main analysis that we did was like a giant linear model, essentially, right? Or at least a linear model with a lot of observations. Then we went through and used a matching approach. Because we did this several ways. Well, actually, the second thing I then did was stratified by age, and went through and checked if we were getting the same associations by age. I then added interaction terms into the model, all 2-way interactions, including all interactions with age, to see if that helped explain, and use a stepwise approach with a Bayesian criteria for deciding, do I include this term? There were no terms which interacted with age that was sufficient to be retained within the model. And then we did like a matching approach where basically you take a set of variables, you match one group to another according to those, using logistic regression approach, which will and that's essentially when you do that matching is going to take into account the interactions, right? And none of that broke the associations; they stayed the same.
So for each decade, 20s, 30s, 40s, you see the same effects basically.
Well, it depends on how you look at it. So essentially with the model where we're taking into account hospitalisation, illness duration, etc., then once those terms are in there, yes. But on the other hand, if you didn't have those terms and just said, were outcomes worse for older adults? Well, of course they were worse for older adults. But it's mostly explained by the hospitalisation, symptom duration, etc. Right.
And my second question is, have you done this equivalent study for kids? And what do you see?
So only with 3,000. We've used the platform in the context of React. It's very experimental because we're doing fully automated online assessments with kids. We went down to age 5. And actually from a protocol perspective, it was a big success. So 5-year-olds, they're more compliant than the 15-year-olds, which maybe isn't that surprising. But they can do it. We just kind of engage the parents at the beginning. So the parents get there, sit the kid down, get them going, the kids are off, it's fine. So far, we've not finished analysing the data, and I think if the effects are subtle, and particularly if you think about all that superimposed on the steepness and complexity of developmental curves, we need a bigger sample. So now we've validated the protocol, we will upscale, hopefully. Does that make sense?
Yeah. Thanks.
You said that people who have long COVID or COVID for a long period, that if they recover, that it looks as though they might get back to something
approaching normality. Yeah.
And since I have a daughter-in-law who had long COVID for 2.5 years and has now come out of it, but it's a personal interest, as it were. Did you have actual data on that? Because you seem to be a little reluctant to say whether there was a real result there.
It's a really good question, but yeah, I was being deliberately cagey because what I don't have at this point in time is the longitudinal data to support that. It's just those who have and those who have not resolved, right? As a cross-sectional comparison. But at the moment, right now, we're actually going out to the next React long COVID time point.
Yeah.
As opposed to going out at 800,000, I'm actually going out to all 2.4 million. So I'm going to email these people 4 times. So 10 million emails. And we will, on the ones who are in this study, we will have that longitudinal data, and I would expect in the intervening time some will have recovered. So I'm going to address that question. Yeah.
How do you define recovered?
We define recovered as having no longer having any symptoms.
Yes. Do people lie?
Probably sometimes, yeah. I'm not sure what I can do about that. But
I'll give you 2 minutes to warm up into more questions. Geography.
yes,
You have enough data to do the famous UK map of cognition and COVID.
yes,
And there were quite a lot of differences in geography in terms of initial intake of vaccines and
yes.
Problems in different counties about access to ICU and etc. etc. Is that something in the pipeline, something that you sort of took a whiff at?
Sort of, yeah. It could be looked at in a lot more depth. So one of the things that we control for is IMD, so Index of Multiple Deprivations, and the IMD is based on people's postcodes.
Yeah.
So we have that information, and what that is factored out of the analysis as a confound. It was also included back in the analysis as a potential interaction term, and then it was dropped out because it didn't explain very much, right?
Okay.
But again, things like severity, illness duration, etc., could have varied, and if those are explaining the variance, so like I say, it could be looked at in more detail.
Yeah. It's always interesting because there was a lot of discussions, in 2021 about, how much the different areas were affected depending on the capacity of the hospital capacity at the local level.
Yeah, and there was that blip early in the pandemic, right? Where even modelling these things in didn't seem to entirely explain the cognitive deviation from expected.
Yeah, and I was like, you have to take it into account. I mean, this is so basic for policy, right?
Mm.
So I was wondering whether.
Yeah, it's an important question to